All right, this is the second part of section 2.7, the use of absolute value functions and their transformations. In the previous presentation, we talked about the transformations associated with the absolute value. Now what we're going to do is we're going to put this into the general case. This is a fairly important lesson because this concept carries on throughout the rest of your Algebra 2 and also continuing down into either your pre-calculus or your trig. The general phase shifts, if you will, are consistent throughout all our mathematical concepts. Just the shape of the original graph will be the thing that will actually change. So, to take what we learned in the previous section and apply it to this section, if we have any function, right? A function is just a fancy word for us for right now to represent a type of an equation. But if we have a function, right, in the form, or I'm sorry, if we have a function, then what we can do is we can say that we can manipulate that function by multiplying it by some constant or by changing the input by some value h, or changing the function by adding some value k to the function at the end of its manipulation. Alright, so what we're going to focus on is, at the beginning, very similar to what we did in the previous presentation. If we have a constant a being multiplied by our function, we continue to call that the stretch or the shrink. So all that's going to mean is that our shape is either going to expand vertically or it's going to shrink vertically. Alright, and we're going to take a good example of that here in a second. Now, one unique thing to also kind of throw in there is if we do have a negative, alright, what that causes our graph to do is that's a reflection about the x-axis. Again, we're going to dive into that a little bit later on in this course when we start talking about quadratics. But the good thing to remember is if we do have a negative, that's going to cause a reflection. But for right now, we're just going to predominantly focus on an a value that is either greater than 1 or less than 1. In our example, that we will show a negative of how that changes. The h is the value inside the parentheses, and that's our horizontal shift. The thing to note that it is written in the forms x minus h. So if we have a minus h inside parentheses, remember this will actually shift to the right. And if we have an x plus h, that will actually shift to the left. A lot of students often get that confused, and we kind of made that point in the previous presentation when we showed actually how the table of values affected the graph. And then finally, the vertical shift, if we are adding a constant, this will be an upward shift. If we are subtracting, we are going to have then a downwards shift. And most graphs have a critical value that we can shift, or we can go ahead and plot all the points and shift every point individually. For our example, what we're going to do is we're going to just get a little bit creative, if you will, and we're going to say y equals f of x, such that the graph of f of x produces our shape here, which I try to draw a fish as best I can. Now, I understand that this is not a function because it does not pass the vertical line test, but for sake of argument for this presentation, we're going to use this graph. And our focal point on this graph is going to be his eyeball. So if you look, I try to plot his eye at the point 1, 3. So here's our original function. All right, we have a fish whose eye is at 1, 3. So if we take our original function and then we do the following manipulations, we have 2 times the function x plus 4 plus 1. What this is going to do is, let's first see that this tells me I'm going to shift it left 4 units and up 1 unit. So the focal point on our function, if you will, is the eyeball. So I'm going to move this left 4, 1, 2, 3, 4, and then up 1 to right about there. So there's the new eyeball of my fish. Now we look at 2. Right? 2 is our stretch or shrink. Since 2 is larger than 1, our fish is actually going to expand. So if we had to estimate what the graph would look like, our new green function will be twice as big. So kind of distorted little fish. His eye is not perfect, but that's the best I can with my artistic ability. The point here is that the fish actually shifted left 4 and up 1 because of what our manipulations algebraically were, and then it doubled in size because our value was greater than 1. So now let's look at another example. Let's use the same thing. Let's use our fish. But now this time, we're going to shift to the right 1 and down 8. So if I start off here again at my focal point, the eyeball, I'm going to move to the right 1 and down 8. So there is now going to be the eye. Since technically the absolute value of A is 1, the fish is going to stay the same shape, but as we talked about, that negative means it's going to actually be a reflection. So how is our fish going to be reflected? He's actually going to be like so. If you can envision that, our fish is now upside down. So if this was his belly there, unfortunately our fish now is belly up. Again, this is a concept that's going to be applied more into Chapter 4 with dealing with quadratics. But again, these are our 3 main shifts that we have. We have an A value, which is our stretch or our shrink. We have our H value, which occurs inside the grouping symbols, which will tell us a horizontal shift. And then we have our K value, which is outside the grouping symbols, which will be our vertical shift.